In the last couple of videos, we examined the thread pool that is automatically created by libuv anytime we start up a Node program. That explained the presence of this pending operations array inside of our event loop. In this section, we're going to start to look at the stuff that's going on behind the scenes to explain this pending OS tasks array right here. We're going to take a very similar approach to what we did previously. So we're going to first start off by writing out a little program that is going to run some code that's going to benchmark a function inside the Node standard library. We're going to benchmark it, and then we'll be able to kind of derive some understanding of what's actually going on behind the scenes. So we'll first get started by creating a new file that's going to house the benchmarking code. Inside of my code editor, I'm going to make a new file called async.js. So the benchmark that we're going to do is to fetch the Google homepage. We're just going to make a request over to Google. We're going to get their homepage, and then we're going to calculate exactly how long that takes. We'll then do that process multiple times, and we can use that to kind of figure out exactly what's going on behind the scenes. So at the top, we're going to require in the HTTPS module to make the actual request. If you've never used this module before to make a request, don't sweat it. It's going to be relatively straightforward. Immediately after we require that module in, we will then store the starting time of our benchmark with a date.now. And then immediately after that, we'll make our actual request. So I'm going to write out https.request. The first argument is going to be the URL that we want to make our request to, which in this case is https://www.google.com, like so. And then the second argument is a callback function. Now the argument to the callback function I marked as res, but this is not like when you're using Axios or jQuery. This is not the entire response object right here. Instead, this is an object that emits events as we receive data from Google servers. So it's a little bit more complex and low level than some of the networking libraries that you might have used before. Basically what that means is we're going to have to write some fancy looking code inside this callback. I'm not going to talk about what this code is doing too much because honestly it's not really at all relevant to what we're doing right now. So I'm going to say res.on data, and then as a second argument I'll pass in an empty function, and then I'll also do res.on end, and I'll do another arrow function, but inside this one we'll do our actual benchmarking. So I'll say console.log date.now minus start time. And then one last line of code inside of here. After the request.call closing parenthesis, so like right here, to actually get this request to be issued, we have to call .end on it like so. Now when I save it, my code jumps on the screen because I have a code reformatter. But basically just don't forget to put on that .end. All right, so let's now flip back over to our terminal. We're going to run this file and see how long it takes to make this request. So over at the terminal, I'll do node async.js, and I see that it takes about 270 milliseconds, maybe plus or minus a couple, to make the request over to Google servers. And it looks like I'm kind of around maybe 240 now. Okay, so this looks good. Let's pause right here, and then we're going to use this code to do some more benchmarking in the next section, and that's going to give us a better sense of what Node is doing internally to handle network requests. So quick break, and I'll see you in just a minute.